Hello student, today we are going to discuss about the speed of a moving body. When a body moves, it covers certain distance or it travels certain distance. Therefore, the ratio of the total distance travelled by the body to the time taken is called the speed of the body. It is a scalar quantity. Why scalar quantity? Because the speed of the body does not give any information about the direction of motion of the body. Speed is a scalar quantity because it does not give any information about the direction of motion. SI unit is meter per second and dimension is L1 to the power minus 1. That means during the derivation of speed, we do not require any mass. So, what is the dimension of speed? L1 to the power minus 1. We already discussed about the speed in our class 9 chapter. What is called uniform speed? During that study, we heard about 2 to 4 different names of the speed. Uniform speed, variable speed, average speed, instantaneous speed. Actually, when we say about the speed, we normally define or we normally call about the average speed of the body. Average means total distance travelled divided by total time taken. What is your percentage? If someone asks, say 92%, 87%, so 92% percentage is the average marks that you get out of 100. So your marks in different subject may be same. If marks in different subject is 92, then also your percentage is 92. But generally what happens? Marks in different subjects are different. You are getting different marks in different. But what is the average mark? That average mark, when calculated out of 100, is called your percentage. So if you get equal marks in every subject, then you are getting uniform mark. The same thing happens in uniform speed. When a body covers equal distances in equal interval of time, whatever small the time interval may be, if a body covers equal distance in equal interval of time, then body is said to move with uniform speed. Our information is more correct if the time interval is as small as possible. What is called variable speed? If a body covers different distances in different interval of time, then speed of the body is said to be variable or non-uniform. If a body covers different distances in equal interval of time, then speed of the body is said to be variable speed or non-uniform speed. So in this case, the ratio of total distance travelled by the body to the total time taken is called the average speed. And if the speed is uniform, average speed is equal to uniform speed. If the speed is uniform, average speed is equal to uniform speed. But when the body travels different distances in equal interval of time, the ratio of total distance travelled by the body to the total time taken is called the average speed. Here we want to discuss about a particular situation. Say, a body travels from A to B. A body travels from A to B. A body travels from A to B. What is the distance of separation between A, B? It is d1 with speed v1. A to B, its speed is constant. B to C, it traveled with speed v2. What is the distance between B and C? It is d2. That means the body moves with variable speed. Initially, body start the motion with speed v1 and then he changes the speed to v2. So under this situation, body is said to move with variable speed or non-uniform speed. So what is average speed? So what is total distance travelled by the body? d1 plus d2. The distance between AB d1, BC d2, total distance travelled is d1 plus d2. Now what is total time taken? We have to calculate. From A to B, it travelled with a speed v1. What is v1? Distance by time. What is v1? Distance by time. Distance is d1, time is t1. So what is t1? d1 by v1. Similarly, what is v2? d2 by t2. So what is t2? What is t2? d2 by v2. So therefore, total time taken is t1 plus t2. So d1 by v1 plus d2 plus v2. d1 by v1 plus d2 by v2. So average speed, total distance d1 plus d2 divided by d1 by v1 plus d2 by v2. That means if a body travels d1 distance with speed v1 and then d2 distance with speed v2, average speed is d1 plus d2 divided by d1 by v1 plus d2 by v2. But if distance d1 and d2 equal, that means from A to B distance and from B to C distance are equal, then what is average speed? D plus D twice D, D by V1 plus D by V2. If I take D common, 1 by V1 plus 1 by V2, I take the LCM. So we get average speed twice V1, V2 divided by V1 plus V2. যদি তোমালোকে অল ইণ্ডিয়া এক্সাম দিম বুলি ভাবিছা, এই ফৰ্মুলাবিলাক মনত ৰাখিব লাগিব। Okay? So this is the average speed if d1 is equal to d2. Now we want to discuss a different situation. Say a body moves from A to B with speed v1 for time t1 and then from B to C with speed v2 for time t2. That means the moving body travels certain distance with speed v1 for time t1, then change the speed to v2 for time t2. So what is distance between A, B? v1, t1. Velocity, speed means distance by time. So what is distance? Speed into time. What is the second distance travelled by the body? v2, t2. So what is total distance travelled? v1, t1 plus v2, t2. What is total time taken? t1 plus t2. So what is average speed? v1, t1 plus v2, t2 divided by t1 plus t2. Yes or no? So this is the average speed. So we discussed two different situations of variable speed and then we calculate what is the average speed under that situation. Now again we return back to the uniform speed. But note বুলি দিছো, আমি সেই নকলেও হয়, কিন্তু মই তোমালোকক সিচুৱেশ্যনটো ভালকে ভিজুৱেলাইজ কৰিব বিচাৰিছো। We want to visualize the situation of uniform speed nicely. Say a body travels along a straight line according to this equation. S is 3t. S2 distance মিটাৰত আছে, t2 টাইম সেকেন্ডত আছে। মেথছত তাকে as function of t বুলি কয়। তাৰমানে distance is a function of time. ফাংচন মিন্স কণ্ডিশ্যন। এই টিটোক ইণ্ডিপেণ্ডেণ্ট ভেৰিয়েবল বুলি কয়। টাইম ইজ অলৱেজ ইণ্ডিপেণ্ডেণ্ট ভেৰিয়েবল আৰু ডিষ্টেঞ্চটো ডিপেণ্ডেণ্ট ভেৰিয়েবল। That means this dependent variable depends on this independent variable according to this equation 3t. This condition may be different also. A condition to different to hobo pare. S is equal to 4t square. Sorry, 4t. Condition to enuko hobo pare. S is equal to 2t. S is equal to 4t plus 2, like this also. Now, when t is 0 second, distance travel according to this equation 0, 1 second, 3 meter, 2 second, 6 meter, 3 meter, 3 second, 9 meter, 4 second, 12 meter. That means after every 1 second increase of time interval, 3 meter, 3 meter, 3 meter, 3 meter. So we say that body moves with uniform speed in this case. Therefore, we want to calculate the speed during the interval 0 to 1 second. So 3 minus 0 by 1, 3 meter per second. 1 to 2 second, 6 minus 3 divided by 2 minus 1, 3 meter per second. 3 to 2 second, 9 minus 6 divided by 3 minus 2, 3 meter per second. 3 to 4, 4 minus 3 time, and distance travel 12 minus 9, 3 meter per second. So in every 1 second interval, the ratio of distance traveled by total time taken is constant. So this is the case of uniform speed. So if I take the time interval 0 to 4, 12 minus 0 by 4 minus 0, 3 meter per second. If I take the time interval 0 to 2, then also 3 meter per second. If I take the time interval 2 to 4, then also 3 meter per second. আমি এখানে ডেফিনেশনটোত কওঁ, if a body covers equal distance in equal interval of time, whatever small the time interval may be, the speed of the body is said to be uniform speed. Or if the ratio of distance traveled to the time taken remains constant for every possible time interval, then body is said to move with uniform speed. If ratio of the total distance to the time taken remains constant, whatever be the time interval, then body is said to move with uniform speed. Now, if we draw it graphically, distance along y-axis, time along x-axis. Generally, independent variable is always taken along the x-axis and dependent variable along the y-axis. When t is 0, s is 0, t 1 second, s is 3 meter, t 2 second, s is 6 meter, t 3 second, s is 9 meter. So if I put these coordinates and join it, it will be a straight line inclined to time axis. That means if a body move with uniform speed, the position time graph is a straight line making certain angle with time axis. Position time graph is a straight line making certain angle with time axis. But what is speed time graph? It is also a straight line, but it is parallel to time axis. There is another definition called instantaneous speed. Speed at a particular instant is called instantaneous speed. It is written like this. It is the ratio of delta S by delta T when delta T tends to 0. Speed at a particular instant Initially, we take the interval 0 to 1 second, 1 to 2 second, 2 to 3 second. So, if my interval is like this, 1 second to 1.00001 second. Initially, we take the interval 1 to 2 second. Instead of taking 1 to 2 second, if I take the interval 1 second to 1 plus by 1.00001 second. So what is the time interval? What is the time interval? 0.0001. So can you measure that interval? That interval is called delta t tends to 0. So under that situation, the speed of the body is called instantaneous speed. And this is the mathematical symbol ds by dt. It is called differential coefficient with respect to time or derivatives with respect to times. এই ফৰ্মুলাটো তোমালোকক মেথছত ক্যালকুলাস বুলি চেপ্টাৰটোত পঢ়াব। ক্যালকুলাস দুই ধৰণৰ আছে, এটা ডিফাৰেন্সিয়েল ক্যালকুলাস আৰু এটা ইন্টিগ্ৰেল ক্যালকুলাস। ডিফাৰেন্সিয়েল ক্যালকুলাসত এইটো বিগিনিঙতে তেওঁলোকে ডিফাইন কৰিব। So our definition to কি কৈছে, instantaneous speed of an object at an instant is defined as the limiting value of average speed in a small time interval taken around that instant, provided this time interval approaches to 0. It is the limiting value of average speed in a small time interval taken around that instant, provided this interval tends to 0. In my case, মই কৈছিলো 1 second to 1.00001 second. তাৰমানে we take the one time around 1 second. And the interval taken, it is very, very small. So under that situation, the value of speed is called the instantaneous speed. এতিয়া কথা হ'ল যে এই গ্ৰাফটোত আমি কিয় আঁকিলো? Why we draw these two graphs of distance time and speed time for uniform speed? What this graph gives us? Now we want to discuss that. So this is the distance time graph. This is the distance time graph. Is not it? This is the distance time graph for uniform speed. It was a straight line to us. A is the position of the body at time t1, B is the position of the body at time t2. This distance is s1, this distance is s2. This distance is s2. So what is total distance traveled by the body from A to B? Delta S is s2 minus s1. What is time interval from A to B? Delta t is t2 minus t1. So what is average speed? Delta S by delta t. Average speed is BC. Delta t is AC. ACB is a right angle triangle. Yes or no? This is a right angle triangle. This is called base. This is perpendicular. This is hypotenuse. AC is called base. BC is called perpendicular. AB is called hypotenuse. So average speed is equal to BC by AC means perpendicular by base. As a result, tan theta. Tan theta is also called gradient or slope. So slope of this straight line gives us the average speed. That means if we know the position times straight line of a body moving with uniform speed, then slope of that straight line gives us the average speed. Okay? Now what is the speed time graph gives us? So this is speed, this is t time for uniform speed. Have you seen it? From here to here, time interval t minus 0. From here to here, interval is v minus 0. It is almost a rectangle, or you may take it as a square. What is area? Area means length into breadth. So v minus 0 into t minus 0. So vt. So speed into time gives us the distance travelled by the body. Therefore, area under the speed time graph gives us the distance travelled by the body. Distance travelled by the body. Area under the speed time graph gives the distance travelled by the body. That means if we have position time graph or distance time graph, the slope of the graph gives us the uniform speed. Or if we have speed time graph, area under the graph gives us the distance travelled by the body. Amar logot jodi position time straight line to thake uniform speed or uniform motion or the slope of the straight line gives us the uniform speed. Or if we have speed time straight line or speed time graph for uniform speed, area under the speed time graph gives us the distance travelled by the body. Okay? Now, today we want to stop this lecture here. Okay? From these lectures, we have found that speed is a scalar quantity. Speed is also a scalar quantity. SI unit of speed is meter per second. If a body covers equal distance in equal interval of time, the speed of the body is said to be uniform speed. Or if a body covers different distances in equal interval of time, speed of the body is said to be variable or non-uniform speed. And in non-uniform speed, in case of non-uniform speed, the ratio of total distance divided by total time taken is called the average speed. Okay? And what is equation of motion for uniform speed? It will be like this. S is equal to 3t. T'r ওপৰত স্কুৱেৰ বা কিউব একো নাহে. T'r ওপৰৰ পাৱাৰটো 1 হ'ব লাগিব. ইয়াত 3, 4, 5, 6 যিকোনো থাকিব পাৰে, +2, +3 থাকিব পাৰে. The power of t is 1. So that equation represents the uniform motion. In case of uniform motion, what is the speed time graph? The speed time graph will be a straight line parallel to time axis. And position time graph is also a straight line, but it is inclined to time axis. And what is the position time graph gives us? The slope of the position time straight line. Slope of the position time straight line gives us the slope of the position time graph gives us the uniform speed. Slope of the position time graph. And area under speed time graph gives us the distance travelled by the body. Okay? And also we discussed about the instantaneous speed. And what is instantaneous speed? The speed of a body at a particular instant is called instantaneous speed. It is also the limiting value of average speed when time interval is taken very small, that is delta t tends to 0. Mathematically it is written as ds by dt. কিন্তু এটা কথা কওঁ, এইটো কিন্তু ds divided by dt নহয়. This d by dt, ds by dt, this is called differential coefficient. That means when time increases by amount dt, so this is the increase of, or this is the distance travelled by the body. Okay, with this I stop this lecture.